Hi. Hi. Can everyone hear me? All right, good. Sounds like you can. All right, well, it's an honor to be here in Austin. I'm a little intimidated, to be candid, giving a talk in Austin because it's such a cool city. I haven't been cool since I lost my hair, so it's a little bit of something. It's so cool. Like, I don't know if they did this for the other speakers. They actually put like artisan vodka in my room, and there's this picture in my room of a Technics SL1200 Mark II direct drive turntable, which is the coolest turntable in existence. DJ Jazzy Jeff uses it. That's how cool it is. So I'm a little intimidated. Bear with me if I can't rise to the challenge of Austin. But yeah, I work for Granbury Solutions. Does anybody here in the talk actually work in the point of sale space? Anybody work on point of sale software for a living? Okay, good. We're going to take some of my artisan vodka and start a support group right after the meeting here, because I think you'll uniquely understand this. So because I'm not in consulting, I'm not here to evangelize an open source framework or any product. I'm just here to kind of explain. I'm in a weird space. We had a weird problem, and we used Selenium as part of a larger strategy to solve our problems. And I just wanted to share it with you. And you might be able to take some of the concepts that I share and take it back to your company and make things better. You might be able to come to me and say, hey, stop doing that. We'll see how it goes. So we had a complicated testing problem. Essentially, we had a legacy point of sale product that had to be rewritten, and that's a dangerous proposition. And so we didn't have a whole lot of testing around the early system, so we kind of had to test two systems at once. And we needed a solid architectural foundation. You know, oftentimes the resources that test people are given, you end up just going away, banging out JUnit test cases, and just trying to make do with XPath. That wasn't gonna. We needed something a little bit more formal than that. But we didn't want to go too formal, too ivory tower. If we were going to build this one proprietary piece, we wanted to make sure the rest of the stack was pretty conventional, uncontroversial. And so we're in the Java ecosystem. I was thrilled to hear Simon this morning defend Java. Remember the guy who slow clapped in the middle of that? That was me, by the way. So I love Java. It keeps learning. It learns from Rails. It learns from Node. It's getting better and better all the time. And so we're using things that are pretty non-controversial: Spring, JUnit, Selenium WebDriver, and Jenkins. Nothing there too crazy if you're in the Java space. And so what's interesting about what we do in point of sale is this is where our servers and technology live, in these really chaotic, crazy environments. Most of you who make web software, you're used to the code you deploy going off to some magical cloud somewhere. You're never going to see the building because Jeff Bezos has not disclosed their locations. And you're used to not worrying about physical security at all. The physical security of the box is the last thing on your mind. In our case, it's a very real concern. Our systems have to run even if the internet's not up. So we put servers inside these restaurants, and restaurants are not known for their attention to physical security. So it is possible for someone to walk in with a thumb drive and wreak some havoc. And so that's part of the world that we have to deal with. Not possible in our system, by the way, but in some others. All right. So here's the problem I was talking about. What you're looking at here is an extremely modern and beautiful screenshot of a product that we have called Firefly. Now, they made the decision that this needed to go away. Now, and that's a tough thing to do, because even though it doesn't look like much now, back when Firefly was first created, it was the first LAMP stack point of sale system ever built. If you've ordered pizza in America more than 3 times, one of your orders went through this system. So it does a whole lot. But it was built in PHP in kind of a haphazard way, not a lot of rigorous testing initially. It kind of had to be bolted on later. So we had to replace it. And this is a very dangerous proposition, because point of sale is way more complicated than you think it is. You might think, well, what's so hard about it? You walk up to a touchscreen terminal, you start pressing buttons, you enter an order. It's not even close to that simple, especially because we specialize in pizza, which is crazy. So pizza you can split a pizza in half, you can have extra toppings, you can order a specialty pizza with certain extra toppings. All the pricing math around that's really complicated. Then you have all the coupons that go into pizza. Coupons are always a factor in different industries, but in pizza, they're part of the marketing of the industry. So coupon interactions, a lot of things that have to be tested. And not just that, but all of the hardware involved. Most of us who make web software, the only hardware you have to worry about is the client's mobile device or browser, which is a complicated enough problem these days. But it doesn't stop there for us. We have to worry about printers, barcode readers, magnetic stripe readers, external Verifone and Ingenico machines, color ID interfaces, all kinds of things, cache drawers. And so that integration is a difficult thing to test. And we can't use Selenium to test that. We can use Selenium to test some things, but not everything. And so we needed to come up with a solution that would do this in a holistic way. And so what we decided we had to do was develop not just a cross-browser, cross-device testing tool like you could do with Selenium. We needed a cross-product testing tool. We essentially needed to describe the test scenarios, the test cases in a DOM-agnostic way that would allow us to define a test case that could run against two different products at once. So even though we are rewriting the old system and the new system, there are certain things that don't change, like the pricing rules and the tax rules and the printing rules. All that stuff has to be ported from one to the other. And the only way to do that is to verify that the same test scenario runs against both systems. And so we built a technique for that. And so the idea was to be able to encode the actual business logic of the test in hipster-friendly JSON. XML, I woke up one morning and XML suddenly was awful, and so we're changing to JSON so that folks with ironic mustaches will be willing to work for us. But the reason for that is the nature of our testing is really, a point-of-sale system does have kind of a core repetitive workflow where you're doing data entry over and over again. Someone comes in, they enter an order, then they enter the next one, then they enter the next one. The devil is in the details. It's a world of 10,000 edge cases. And so if you have a little snippet of JSON that mimics order entry and you run across some kind of edge case, you don't have to take a bunch of boilerplate Java and move it over here to the test case. We can just do boilerplate JSON, which somehow is more acceptable than Java. So that's essentially the idea, is that we can eventually express all of our testing needs in JSON and easily create new test cases. And then, of course, we want all this to integrate into CI so that it's automated. It's not we don't have an SDET or an SQE pressing a button during every release cycle. It's part of the CI process. All right. So I want to talk about myths and resistance. When we initially proposed building this test framework, there was some internal resistance to it. There were folks who said, this can't be done. My God, it sounds like real architecture. You're going to need real software developers for this. We can't do this with interns. And what they were honing in on is, I think, less the complexity of testing and more the complexity of rewriting. So if you're going to rewrite something that's big and complicated, there's no point shipping it if you don't test it. And so if you ever run into that kind of resistance, the argument is, well, if it's that hard to test, let's just not build it in the first place. Sometimes, in our case, we didn't really have a choice, so we were moving ahead. And one of the books that I like to use sometimes it is hard, and I think Simon tapped into this morning when he was talking about the sort of resistance, sort of the ghetto mentality that sometimes revolves around people who do testing or quality for a living, which is very, very sad. I run engineering for our team. I'm not from the testing part, so I can tell you that I put quality at the top at the center of what we do from the top down. It's not just within the quality group. And one of the techniques I like to use to convince the business folks that this is a good idea is to go all the way back to 1971 to this book by Philip Crosby called Quality is Free. Who has read this book? Anybody? One person? Okay. I guarantee you most of you have read a book that's referenced this book. So that's why I kind of go back to it, is because this is where zero defect methodology comes from. As flawed as that may be, it's a good sort of thing to aspire to. But the basic argument made in this book is that if you don't do any kind of real testing, if testing is an afterthought, most of you who work for SMB software companies, small software companies, they probably don't do a lot of testing, right? I know our competition doesn't do much testing because they told me in the trade show booth last week. But what this basically says is if you are not doing any kind of real quality, the cost of fixing your mistakes after you ship software, whether it's RMAs or support tickets or emergency bug fixes that cause people to quit in droves, that's costing you 20% of your top line. So if you're taking in $100 million a year selling software, you're spending $20 million fixing your mistakes. If you get quality right to begin with, now it's going to cost you 2.5% of sales. That's the argument made in Quality is Free. It's a really, really good argument to get the attention of the higher-ups. And oftentimes, the higher-ups will respond if someone else says it. So if you come in and say it, they're like, well, you work here. You must be stupid. But if you come and say, no, someone wrote a book. They wrote it in the 1970s, okay? They had sideburns when they wrote it. Take it seriously. Then they'll take it seriously, and that worked at our organization. I sent every executive a copy of that book, and the next day I had funding. It was great. So Another myth is that quality is tangible. I was actually in a meeting recently where someone said, quality is not a real thing. There's nothing specific you can do about it except put it on a bumper sticker and aspire to it. And that is really, really sad when you hear that. Quality is extremely tangible, and the best definition of quality you're ever going to hear comes from that book. What Philip Crosby says is quality is when you measure conformance to the requirements. It isn't some hand-wavy, new age philosophy. It means, does the software do what it was supposed to do or not? And measuring that, that's what we do. So if you get resistance to doing this kind of stuff, just try out this book, and it should work. It worked for me. So this is what we built. We call it Crossfire because the product that we're rewriting is called Firefly, and it's cross-product. So it's clever, right? So because it is a Java-based framework, it has lots of unnecessary layers. I love them. We start with JUnit, very simple. And most of the work, the actual work of the framework is done by kind of a base JUnit class that all the test cases extend. We'll get into more on that later. We describe the test, the actual logic of the test in JSON. We also have JSON environment configuration. This is things like, we don't run on Sauce Labs. We run on an actual browser farm that we have in a real facility that runs on the same hardware our customers use. And so we have different environment configurations depending on whether they're running on the iPad Pro or on a touch dynamic machine or a partner tech machine, something like that. And so we use Jackson to parse the JSON, assisted with Spring, and I'll get into that in a minute. And then we have this notion of a product driver. And the product driver's job is to take the product agnostic JSON and turn it into the actual code that's going to run the test. We call them command handlers. They're basically an abstraction above page objects. And then, of course, we have page objects, and they interact with Selenium WebDriver. We also interact with some other services that do some things we need to do with testing that are not necessarily Selenium-based, and I'll get into those in a bit. And we have a little system called Graybox that does that. So that's kind of the summary, and I'll work my way down this stack briefly here. How many of you are familiar with Spring? Right? I love Spring. It's become sort of the kitchen sink in Java. It does a lot of things that maybe you don't need all of it, but at its core, Spring is dependency injection. And I like it because it's a different way to manage page object dependencies in a test framework. And so this is a good example of you put a service annotation on a class, you put a component annotation on another class, and the auto-wired annotation will go out and find an instance of that other class and wire it for you. So you don't have to manage factory patterns or anything like that. And this is a really well-established, anybody in your team that does Java, there's a good chance you're probably already using Spring. If you're not using Spring, you're probably using something like Drop Wizard or Juice, which is going to have some similar things in it. So Spring is great. So this is what our actual JSON scenario files look like. This is a really simple one. As you can see, they're very, very complicated. It's just a name and then an array of commands. And those commands get deserialized into POJOs, just plain Java objects, if you're not familiar with our lingo. The only part of this that really has to be consistent across different types of commands is the command name, login. That's used to figure out what class I'm going to turn that JSON into. And then the rest is proprietary to whatever the command does. In this case, the command is going to log somebody in with that ID and make sure that it actually worked, and then set a few things about their session. Right? And then this is the actual JUnit test case you have to implement. We could have gone away with this altogether and just maybe said scan a directory of JSON files, but there were reasons why we felt like that was a little bit too black box. We wanted something a little more explicit. But all you really have to do here is extend our CrossFire Support base class, and then override this getScenarios method so you can return an array of scenarios. The reason that we have an array instead of just one is there might be something in a scenario file that you're going to reuse all the time. Maybe it's going to be setting up the credit card processing configuration for a certain provider. You might want to set up Vantif or Mercury for this test run versus another, that sort of thing. Right? Let's see. Here's another look at a command. This is our menu item select command. Its job is to find the button on the screen that says cheese pizza, push it, and then make sure the virtual ticket, that's what we call the thing on the screen that looks like a receipt, that the pricing all works as you expect. And you might say to yourself, why would we have an expected item price of $7 and a total of $5.30? The answer is automatic discounts, yet another edge case that we have to deal with. So in that scenario, that's what's happening here, right? All right. And so here's one of the POJOs that we turn these JSON snippets into. The JSON commands get turned into these Java objects. They're POJOs for the most part. There is this notion of an abstract command, and all it does is basically make sure that this get command method has to be implemented. This just has to match whatever command colon is in the JSON. That's the only purpose of it, right? The rest is completely up to you as an implementer. All right. Here's our extremely sophisticated and cutting-edge Jackson deserializer. So when we parse this JSON, the only thing that JSON off the shelf doesn't do for us is it doesn't know what class we want to use for each command. If there's an array of commands, we have to tell Jackson. And the way that we do that is we just make sure the classes themselves that we use to implement commands can be managed by Spring, and then we put together a little map here of the command's name to the class, and then that's used by the serializer the deserializer to parse the JSON. So that's the only hack that we do. Here's a little more detail on that. This is pretty plain vanilla use of Jackson, if you're familiar with it. The first 4 lines where we do our special stuff, and then the scenarios themselves, actually, the JSON files, they live with the code in the resource directory. So they're considered resources. So they live with the code. That's basically it. So when we get done with this, we have a test scenario POJO that has a collection of commands that have been parsed for us, and we can pipe them into the test framework, which we'll go ahead and do. We also have environment configuration. So since we're testing, our system is web-based. It's a web-based point-of-sale system. And obviously, we have to point the test environment at a browser, at a URL, set a couple of settings. And this is where we do all of that. We also have external systems we integrate with. For example, has anyone ever ordered pizza on their phone or on the web? Right? Well, that's yet another system, right? So we have to test, if I place an order on the website, does it show up in the point-of-sale system? Those two things have to work together. So this is how we test that. And so one thing that's interesting here is the closed browser setting. So this gets into the scenario where for a given test run, you might want the browser to close after every single test run, no matter what. That would be in the CI environment. You don't really care. But if you're working on the test locally, you want the browser to stay open so you can keep doing the next DOM exploration task that comes after that. Because being an SDET or an SQE is basically about punishing yourself by trying to reverse engineer someone else's DOM. That's a huge chunk of what we do. And so that's for that. All right. One of the first things that the test framework does when it parses all this stuff and fires up is it has to figure out what WebDriver we're using. Anybody who's done something non-trivial in WebDriver has probably created something like this. Some kind of, it might not be a switch case, but it'll be something. And our real implementation isn't quite this simple. We don't just take the drivers in their plain vanilla form, but it's really nothing more complicated than that. But one of the things that our environment supports is you can specify in a test run that you're targeting multiple browsers at once. And so it basically goes through this process twice. Right? OK. The product driver. So the product driver's job is really, we have this notion of a command handler. And that's the actual class that does the real work. And this could be different if I'm testing with my Firefly product versus my Thrive product. And it's the product driver's job to based on the environment configuration, to figure out what command handler we're going to run for this particular situation. And so that's all this does. And it's not very complicated. This is pretty plain vanilla stuff here. All it does is resolve the driver. This slide is more of a confession than anything else. All right. And then once we have all of this, we have a driver, we have our product driver, we have the web driver. Then all we do is loop over the commands. This is called a for loop. Anyone familiar with these before? Anybody know these? OK, good. I know I should change it all to streams now that we're in Java 8. So I'll do that for next year. All right. And this is the command handler interface. So the interface of all the classes that do most of the real testing work. The first two methods here, all they do is identify it. What command class is this for? What product is this for? Then you have the execute method that takes we're using generic, so you can pass in, so you can use you don't have to cast things once you have a command. And then it passes in this stuff and does all of its work, right? And here's a sample of the command handler. This is our menu item select command handler. Any idea, so we're auto-wiring in a few dependencies with Spring. Any idea what those things would be? They're page objects, right? So we have a virtual ticket that gets wired in automatically. That is the page object that lets us deal with the little fake receipt on the screen. And then the menu itself deals with all the buttons that we might want to press. And so that's how we can share all these dependencies across the system without having to come up with our own factory patterns. And they can also maintain state. That's one of the reasons that we like to do it. And then this is an actual, this is a somewhat simplified version of the execute method. And most of this is, we're delegating down to page objects, the kind of stuff you would, if you're using a very simple Selenium JUnit with a page object pattern, this is probably the code that would go in your actual JUnit test case. But in our case, it goes down the stack a little further. Right? We're doing good on time. And of course, we have page objects. This is just here for completeness so that we really have them. But I think most of you probably already know what page objects are. And in this case, we actually interact with Selenium. So finally, a talk about Selenium actually gets into some real Selenium stuff. The ubiquitous find elements method. And that's what we do. All right. So that's kind of part one, the architecture behind this, which is we go from JSON to WebDriver by putting a little layer in the middle that allows us to switch the logic we're testing with based on the product. That's called the ProductDriver. And the basic idea behind this is that we've created our own domain-specific language for restaurant/pizza point of sale. We could have tried to come up with some kind of abstraction that we could open source, maybe use something like Cucumber, but we decided that we wanted to focus really on the problem we were trying to solve and not try to anticipate what your problems might be, because we're a relatively small software company. As I've said before, I think a lot of you probably work for companies whose lawn care budgets are more than our entire engineering budget. So we have to be efficient in what we do. And the basic idea behind this is that if you do enough development of the underlying framework, eventually most of the edge cases you come across in testing can be modeled in JSON. Now, in reality, you're never going to get there all the way. You'll stumble across something you need to test that requires extending a command, adding a command. So you're always going to have an SDET that knows what they're doing kind of in the mix. The idea is that as time goes on, there could be a way to ramp somebody into the testing environment without them needing to have fully mastered Java or Selenium out of the gate. You could start with maybe some interns, some less experienced people to get them up and running. So that's our basic automation framework, and it covers the structure of it. But I think the more interesting part of this talk is the stuff that comes next, which is how do we automatically test things that are really hard to test, that are not the browser, that are physical hardware. That's tough. And also some of the fun. I think some of the first code I ever wrote when I started working for Granbury was to address this hardware simulation problem. So we'll get into that here. All right. First of all, you have credit cards. The horrifying thing about credit card readers, for those of you who don't know, is they act as keyboards most of the time. Your computer just thinks a keyboard is hooked up to the computer. You swipe a credit card. All of the characters on the track are just typed into the computer. That's how it works. That's why keyloggers are so great, so effective for hackers, right? They love them. Now, so the reality is that most modern MSRs, and certainly the ones that we use, they use a public key. It's a little more complicated than that, but it's like public-private key encryption, where when you swipe the card, it is encrypted by the hardware, turned into ciphertext. That gets typed in. And then we ship that off to the credit card processor. They have the private key. They can decrypt it, and that's how it works. But most 90% of the POS exploits involve keyloggers in situations where there's where they're using unencrypted MSRs. So as bad as that is for security, it's good for testing, because all we have to do is take the track data, stick it in a resource file somewhere, and during testing, we read it, and we pipe it in through send keys. Easy. That's how we do it. So that's not one of the hard ones to simulate. But it does make things fun. Printers are where it gets really fun. So how do you automate testing of printers? We thought about some wild stuff. Like, for example, what if we get a bunch of OCR cameras and a big bench full of printers, and we'll just take pictures, and we'll figure out how to make all of that work, and then win the Turing Award. Like we knew it wasn't going to work that way. So we had to sort of break down the printing problem to, OK, what are we really trying to test? You're always going to have some kind of basic physical verification with someone's eye that the paper came out of the printer like it was supposed to. But the reality of our world is what we find ourselves testing more are all of the weird things that can happen to receipts. It's not just that do things print correctly, do they print in the right place? If you place an order in any kind of major restaurant, your drinks are going to print at the bar printer, your salad's going to print at the salad printer, your pizza's going to print at the make line, then you're going to have a credit card receipt. So how do we verify that the right things went to the right printers? And of course, because we're masochists, we allow our customers to configure this a zillion different ways. And so what we decided to hone in on is, all right, we know we can't automate visually inspecting receipts, but what we can automate is verifying that the right things went to the right place. And the way that we decided to do that is we built this sort of simulation tool called Graybox, and it's a little REST API thing that runs alongside the point of sale on the same network as the point of sale. And you can tell it, I want you to simulate a network of printers. And all it does is start listing on a bunch of ports. The point of sale is configured to think those ports are printers. And all printers do essentially is ingest a pile of printer language text, and then they barf out paper. So instead of barfing out paper, we just stick them in a hash table. And then we expose a REST API that says, give me the raw printer job that went to this printer or that printer. And then we can regex that and kind of sanity check that certain things happened or didn't happen as they were supposed to. So that's how we do it. That's how we're able to deal with printer stuff. So when some new requirement comes along or some new little feature in the format of printing comes along, we can write an automated test for it. We still have a process where we visually verify all of this stuff, but the scope of what we visually verify is just sanity checking that the printer, that the whole process works, the little details about what prints where and when. That's stuff that we do in an automated way. All right. We also have cache drawers. For those of you who stuck around to this point in time, you're going to not regret it because I'm going to teach you how to rob a restaurant. Okay? All you need is, I think it's RJ32. It's one of the weird RJ cables. It's not RJ11, it's not RJ45. You need that and a 24-volt battery, and you can open any cache drawer you want. Very easy. So the way that printers work in restaurants, or the cache drawers work in restaurants, is they are an extension of the printer. There's a special cable called the drawer kit cable that you can buy. It connects to the printer, connects to the back of the cache drawer. And when you want to open the cache drawer, all you do is you send a print job to the printer with a special control code that doesn't print anything. It just fires that relay, cache drawer opens. So being able to automate that the cache drawer opens when it's supposed to, and more importantly, does not open when it's not supposed to, it's pretty important in what we do. I mean, it's the kind of thing that we analyze for things like inside threats for security. So it is the kind of thing we think someone could do maliciously. So we definitely have to test that. And luckily, that's pretty easy. All we have to do is piggyback on top of Graybox. And when we send a print job to a printer, we just verify that that control code is in the print job, or that there was no print job sent to a printer, so that we can verify that the drawer didn't open. That's how we do it. We still manually test this stuff, but all those little permutations happen with automation. Cool. I'm going to have everyone sign a release before you leave in case you do rob a restaurant. Okay? Just don't rob one of our customers' restaurants. I'll give you a list of good ones. All right. So caller ID is interesting. I know that you're all cool. I covered the cool thing earlier, but there are still some people who order pizza over the phone, if you can believe it. Right? They also have the Matlock box sets and that kind of stuff. But it is something that we have to deal with. So when you do order pizza over the phone and you call up the pizza place, you may have gathered that they know who you are. So you call up and they're like, oh, do you want the same thing as last time? And this is how we do it. Most pizzerias have one of these boxes in the back. There's only one company that makes these. They're in Atlanta. And essentially what these boxes do is you plug your analog phone lines into them. There are VoIP versions as well. They're just not widely deployed yet because POS is a little behind the times. You plug analog phone lines into this. Ethernet comes out. You just plug the Ethernet jack into the point of sale network. And what happens is whenever a call comes in, the caller ID frame of the analog signal is decoded, turned into a UDP packet, and broadcast over the network. So the way we implement that is we listen for the UDP packet, and then as the phone rings, your screens change right in front of you, just as if you were looking at the caller ID. So simulating that is not too hard. Once we had Graybox, we realized we could add things to it besides just printer simulation. We could add a REST API that says, please simulate this phone call. And so what Graybox does, it just creates that UDP packet itself rather than letting the caller ID box do it. And now we can automate caller ID responses too. So that's how we do that. sadly, we come to some of the really hard stuff. It's good for security that we're moving more to these external devices. If you go into a restaurant and they're using an external device like this, instead of an embedded mag stripe, you are 90% more secure that things are going to work, even if they're not using chip cards. But part of what we have to do now is integrate with these devices, Ingenico, Verifone, PAX, lots of different ones. And so there's really no way to simulate this with automation. We've been really scratching our heads because we want to, there is a lot of variability here. The variation is not just Verifone to Ingenico, but it can also vary by processor. So you can have a different way of doing Verifone on Vantif versus someone like OpenEdge. And so it becomes this sort of Cartesian product situation. So Jillian, who's our test manager, our lead test engineer, and I were kind of sitting around fantasizing one day about, okay, well, how could we really do this? And we thought, what about robots? And at first, it's one of those things where you know if you go to the management and ask them to buy you a robot, they're just going to laugh at you and send you on your way. But the more we thought about it, the more we thought, you know, this is about it. This is about all you could do. So what if you had one of these robots here, and these are about 15 grand, they're not too bad, a rack of machines, a rack of credit cards, and just build a system to do that, right? And that could be a command handler. It could live right in our world, but instead of doing Selenium stuff, it could talk to the robot. So that's sort of the next evolution for us, is to get into that area of it. Our company is building a new office in Dallas, and it is currently planned for us to put an automation lab with this feature in it as soon as it's done, which is this summer. So my hope is next year I can show you guys a robot demonstration. That'd be fun. But I really think that's all we can do, because the point of sale environment is crazy. It's pretty wild. The technical standards in point of sale are not as high as I think some of you are used to. And so people tend to live with certain problems the rest of us wouldn't. And that's kind of how things go. All right. I'll just summarize. You've got to have a summary slide, right? So in essence, we confronted the hardware integration problem and the cross-product testing problem at the same time. And we built an abstraction layer based on JSON. Has a lot in common with behavior-driven development or behavior-driven testing, if you're familiar with that. But I like the idea of pulling business logic out of the testing as much as possible. So we had to do that, and at the same time, we had to expand our ability to test a lot of the hardware integrations and get as much automated test coverage with that as is reasonable. You can't get 100% of it. You can get a good chunk of the way. And the good news is it actually works. So oftentimes in testing, when we go to our higher-ups and we say, you know, we would like you to invest in this, they might react with skepticism. And they did, in our case too. But once we bit the bullet and sort of got the first version of this done, you know, we can now test most of the major workflows. All the different credit card processing scenarios are all covered with this. And it started catching a lot of regressions. And so my boss came to me and said, I would like you to hire twice as many people to work on this. And that never happens in the history of testing ever. Like, when has a golfer come to you and said, let's hire more testers? That just does not happen, right? So it really has worked. It's worked so well that they're going to buy us a robot, and I'm very excited about that. So I think that's all I have. I've been asked by the people I work for to mention that we are hiring. If you think this is fun and want to work on it, talk to me after the show, and we'll see if we can get you guys an interview. Any questions so far? I know I covered a lot in a short period of time. Yes?
Have you ever been through a situation where you want to test a scanner gun, like a barcode scanner, barcode reader?
The question was about barcode scanners and whether or not we test that. Because we're focused on restaurant point of sale, the barcode scan something in point of sale, it's not a super common use case for us. We do support it. There are some people who do it. But we haven't really come up with a way to test that part yet. Although, barcode scanners are typically keyboard wedges, just like MSRs. So you could use the SYN keys method to test barcode scanning as well. Yeah. Yes, sir?
Yeah, you mentioned earlier that you chose to develop this kind of custom JSON route instead of using a framework like Cucumber.
Yeah.
Because you weren't interested in trying to solve future problems. Can you kind of elaborate on what you meant by that?
Well, what I meant was I didn't want to necessarily solve an entire industry's problem, right? I felt like Cucumber was an abstraction that we'd still have to have our own abstraction on top of, although it would be thinner, wouldn't be as much stuff. And I, you know, I'm a huge supporter of the open source movement, but it requires a kind of evangelistic capability that I don't really have. And you know, we're a small company, like I said. And so the idea is if we incept a project and throw it out into the ecosphere and it becomes an open source project, that maybe we won't have to maintain it all on our own anymore. That's the sort of value proposition for the higher ups. But I just didn't think that was a realistic goal for us, given our size and capability. So it wasn't some ideological opposition to it. It was just us trying to be practical in the face of the real problem we were solving. Right? Who's next? How about you?
Yeah, what's your process for developing and validating your JSON test cases?
Well, we call them SQEs. I think some people call them SDETs that work embedded with the software, with the actual teams. And typically, what we do is we start by looking at. We have a manual test plan, and we'll start looking at things that we want to pull out of that and make them automated, and they just start working through it. I'm not exactly sure what the kind of answer you're looking for is, but I can say that it's very informal. Because we're small, there isn't a whole lot of project management red tape around it. We just, the SQEs live with the teams that we build the core product. And they have, on our SQEs, have a lot of flexibility. Like if they run into a situation where, hey, I need an ID tag here or an attribute here to make this easier to test, they just add it. There isn't a firewall there preventing SQEs from modifying the core source code to make it easier to test. One of the litmus tests that I use is, if you're using XPath, it's a symptom of poor collaboration, right? Like, now I'm not saying the folks behind Selenium should remove support for XPath. It's a tool that needs to be there. But if you're using a bunch of XPath expressions, and then you go into a meeting and you say, hey, I have to use a bunch of XPath, will someone help me? And they ignore you, like, it might be time to update your resume and come work for me. Because we don't have that philosophy. We've even thought about adding a check style rule that breaks a build if there's XPath in it. Just to enforce, I think that might be going a little too far at this stage, but I would like to get there eventually. I know that was maybe not exactly the question. My answer didn't fit your question exactly, but good enough? Yes, sir.
You do a lot of cool things. Sorry. Hi. You do a lot of cool things with your framework. How much maintenance goes into this?
Honestly, not that much. Most of the maintenance arises out of discovering the need for new commands. So obviously, we can't identify in advance all of the things that JSON needs to model. And so a big portion of the work is, oh, well, we didn't think of this yet, so let's just add an attribute to the JSON, modify the command handler for that. Or, oh, we need a new command for this because we've never tested this before. So it's not, because the core framework itself doesn't do a whole lot of magic, it's just glue. So there hasn't been a whole lot of maintenance required. The big maintenance task in front of us is the upgrade from Selenium 2 to 3. So that will be a maintenance task that we're about to embark on. That's about it. Yes, sir.
RPO's application is a desktop or Java Swing-based application.
Yeah.
Do you have any recommendation? Because we use Selenium, heavily modified Selenium to actually test that.
Yep.
Do you have any recommendation as to how to test
the Swing stuff?
the Java Swing-based application?
You know, it's been a long, actually the very first automated tests I ever wrote in my life were for Swing many, many years ago. But it's been a long time since I've been in that world, so I really don't know. I mean, I guess you could use an abstraction layer like ours to be able to have some stuff at Selenium, some stuff at Swing, something else, but I honestly don't know. But I think Swing Unit is still around, isn't it? Yeah? Cool. Yeah. What was your question?
I was just going to say, we've already gone down the robot path, differently.
Cool. Good. For credit card testing, or?
For credit card testing.
Really? Yeah. I will give you a bottle of my, he says that his company has already built some of this credit card robot stuff, and so I'm going to give him artisan vodka in exchange for getting his ear for a few minutes. Who's next? Sir?
Yeah, I just want to know how many developers you needed to build the framework, and how long did it take?
It took about a month with 2 people. Wow. Yeah, but again, that was because we deliberately chose to keep it simple. If we had said, we're going to build some open source project that's going to change the world, we might have been right, and that is a noble goal, but it would have taken a heck of a lot more time before we could have shipped the product we're trying to build. So we kept it really, really simple. Yeah, I think if you were trying to solve this problem in an abstract way that works for everybody, all we basically would end up doing is building Cucumber, I think. Right? And Cucumber already exists. We don't need to build it. Yeah. Who's next? See a guy back there.
About the robots, I'm sure you're serious about that.
I'm dead serious.
Why didn't you try to hack into the terminal and attach an interface to keypad pressing?
Because that would be unethical. But an honest answer to your question is we want to test things the way that they're meant to be used. And some of the providers of this technology, they provide sort of cloud-based APIs that simulate the API on the device, so you can sort of simulate that. But I've just learned the hard way. And the thing about restaurant point of sale, I think the only environment, the computing environment that even captures it is more like military type stuff, where you have all these environmental factors, this demand for ruggedness that goes well beyond what most of us are used to. And so I just don't trust an abstraction layer when it comes to credit card processing. I mean, there's a certain amount of abstraction we have to make it automated, but I don't want it to be any more. I would love for Verifone and Ingenico to build. I mean, but if anybody who works in point of sale knows, the credit card processing world is just pure madness. You have this small monopoly of companies that control the whole thing, and I routinely have candidates apply to work for me that work for credit card processing companies. They can't even get past our first screening test, right? So we're not the other side of this problem in the credit card processing world. That we're not dealing with our peers. We're dealing with people who are well below where they should be because the card brands give them a monopoly on access to the card processing systems.
I think I've been misunderstood. So you would basically replace the mechanical press with an electrical contact made by your interface. And I
Yeah.
don't see how it's unethical because you keep it.
Well, it could be. I mean, I said it was unethical because I thought people would laugh, and I was wrong. But the honest answer is it's something we really don't know how to do. We don't have a lot of hardware or embedded type people to help us work on something like that. And the way that it would work would vary depending on whose firmware is loaded on the device. It's not enough. We can't just buy like an MX. Like the common one you see at the grocery store is the Verifone MX915. And the way that device works depends on who your credit card processor is. And there's lots of middlemen so the firmware is also a factor. It's just a problem that I almost feel like doing the robot thing is an easier problem for us to solve than trying to reverse engineer all these other systems. But I could be wrong. And if someone solved the problem for me, I would give you lots of money. So, yes.
One more question?
Yes.
So you said that you not run in the testing team, which is engineer, director, whatever.
Yep.
How do you solve accessibility problems for things you build? It seems like you might be, you have to deal with accessibility, blind people, deaf people. How do you do? What do you do for this?
Actually, at this stage, we don't. It just hasn't come up with it because our software, the software that we spend most of our time testing, is the stuff that the servers are looking at in the restaurants. So there's when our customers come to us and say we need accessibility, I'm sure we'd address it. But right now, it just hasn't come up, and we haven't really had the bandwidth to focus on it. I think it will be more of an issue as we start expanding our online ordering testing capability, for sure.
All right, so it's a great presentation. Let's everyone thank Jeff for his.
Thank you.